And should be good to go. All right, I'm going to be covering tonight sections 2.6 and 2.7. Both deal with absolute value. So 2.6 is absolute value equations, and 2.7 is absolute value inequality. So first off, I feel like I need to talk about like what absolute value even is. So the symbols for absolute value are these vertical bars. Okay, be careful with your handwriting whenever you write it. Like if you aren't paying attention, you'll write it and it'll look like 151. Like these are vertical bars. And what they mean is the distance a number is from 0. All you really need to know is it takes whatever is inside and then makes it positive. So the absolute value of 5 is 5. Likewise, the absolute value of -5 is also 5. So it just takes whatever is inside of your absolute value and then makes it positive. Now, where this gets a little bit tricky is if you're doing some sort of computation. Okay, so if we had something like the absolute value of 3 times 4 minus 6. Okay, the absolute value doesn't make that 6 a positive. It takes whatever the heck this whole value is and makes it positive. So if we follow our order of operations, 3 times 4 is 12. Okay, 12 minus 6 is 6. Then it takes that and makes it positive. So absolute value takes whatever is inside. Once you work it out, it takes that value and makes it positive. Okay, but again, we're going to be solving some equations. So they're going to give us things to do with X. Now I'm going to draw back to this example. And if I said, okay, the absolute value of X equals 5, okay, what is X? What number should X be? Well, even just looking at this, well, if I plug in 5, that gives me 5. But if I plug in -5, that also gives me 5. Okay, so that's one thing we're going to have to deal with. Absolute value equations always have the potential for 2 solutions. Okay, you've got to deal with the positive and the negative. So real quick, dealing with absolute value equations, the steps to solve okay. Step 1, you want to isolate the absolute value. Then you're going to split into 2 equations. Again, solve for the positive and for the negative. That says 2 EQ, 2 equations. You're going to solve both, and then you can check your answers. And then I'm basically going to walk you through a handful of examples, starting really, really simple, getting a little more complicated. Then I'll show you a couple of the wrinkles that they can throw in. Okay, so for starters, they're going to start pretty simple. Okay, something like that. So absolute value of 3x minus 1 equals 7. And again, we're not always going to have these on here, but we're always going to follow those same steps. So isolate the absolute value. That means get this absolute value piece by itself. If there's stuff going on outside, we got to get rid of it. In this case, we don't have that. So we just have the absolute value. It is isolated. It's by itself. So we're going to go ahead and split it up. When we split up our absolute value, okay, one of these is going to look basically the same. We just drop the bars. So we've got 3x minus 1 equals 7. The other, what is inside the absolute value is going to stay the same. So that's still 3x minus 1. So this 3x minus 1 piece doesn't ever change. But now instead of equaling 7, we've got to do the negative of that. So we've got to make it equal -7. So this part, whatever it equals, is where you get the plus and the minus. Okay, then we're going to solve both. So to get rid of the -1, we add 1. So 3x equals 8. Divide by 3. Okay, x could equal 8/3. Now, my math lab likes fraction answers. If you want to change that into a decimal, I think that's fine, but I don't think my math lab likes rounding, so I would just leave it as a fraction. Okay, same game. Add 1. So 3x equals -7 plus 1 is -6. Again, divide by 3, and x would equal -2. And both of those answers should work. I'm going to go ahead and check them. Now, you don't have to show that you checked your solution. You don't even have to check your solutions. I like to, because I want to make sure that it works. So what I'm going to do is I'm going to plug my answer into my original function. So if I take the absolute value, 3 times my solution, -1, I'm going to see, does that actually equal 7? So again, if I do the math, 3 times 8/3 is 8. Okay, 8 minus 1 is 7. And the absolute value of 7 is 7. This one checks out. That math worked. This is a good solution. Okay, again, you don't have to check, but you can. I'm going to do the same thing with -2. So if I plug it in, 3 times -2 minus 1, I want to see, does that equal 7? 3 times -2 is -6. -6 minus 1 is -7, and the absolute value of -7 is also 7. So that one checks out. Good solution. So both of those work. Now, when it comes to the quiz or the test, as far as I'm concerned, this works for me. You're telling me what my x's equal. That is great. Of course, my math lab has to do things just a little bit differently. So when you do your homework here, it's going to give you a couple of buttons to pick. Okay, one looks like a no solution thing. One's a solution set or something like that. And then one says write your solutions as a set separated by commas. And it gives you these kind of squiggledy looking brackets. Okay, in this situation, that's where you're going to put these solutions. Okay, so you're going to type them in. I don't think order matters, but you would type in your solutions into those brackets. That's your set of solutions. So when you go to solve it on my math lab, it's going to look kind of goofy, like there's not a place to just type in or whatever. So you kind of read, you want to click the one that gives you the brackets, and then I think you click in the brackets, and then you can type in your solutions. So my math lab just does something to make it just a little bit goofy because they can. Okay. Doesn't change what it is. You're still finding the solutions, but that's just a heads up on some, like, anyway, mechanics of how they want it done. And like I said, you don't have to show the checking of your solution. You don't even really have to check, but I would if it were me. So get the absolute value by itself, split up. One side's positive, one side's negative. Solve both. And then if you want to, you can check your solutions. But if you get your two solutions, put them in those squiggly brackets for that. Okay, I'm going to do a couple more examples. And again, does the same thing. It gets just slightly more complicated. They're going to do something like, okay, so 4 plus 2 absolute value x plus 1 equals 10. Okay, this is the kind of stuff that's going to be going on outside of the absolute value that you've got to get rid of. Okay, it seems kind of confusing or tricky, but if you think about it like you would any regular equation, so just kind of on a side here, if I said 4 plus 2x equals 10, okay, you guys know what to do. If we're trying to get x by itself, you're going to subtract 4, and you're going to divide by 2. Okay, Same steps here. So this absolute value piece is what we're trying to get rid or trying to get by itself. So we've got to get rid of this. And while you don't see the symbol here, that's like saying times. So this is 4 plus 2 times that. Okay. There's a couple of things that people try to do or they have an instinct to do that is wrong. So people will first just try to add that 4 plus 2. Can't do that. Okay. Again, if we're multiplying, you can't do that. Or they'll try to distribute. Same thing. Can't do that. So these same steps is what you're going to do. If I want to get this absolute value by itself, I got to get rid of this plus 4. So again, I'm going to subtract 4. So that goes away. Four minus 4 is 0, so that's gone. 10 minus 4 is 6. Now, if I can't distribute in, but I still got to get rid of this 2, remember the opposite of multiplying is to divide. So step 1, you got to get the absolute value piece by itself. You do that by doing all of your same equation solving techniques. The opposite of adding is to subtract. The opposite of multiplying is to divide. Okay. And that's really about as complicated as it gets as far as what's going on the outside. They don't do a whole lot else, but they do a handful of those problems. Anyway, once you actually get the absolute value by itself, this is where you need to split it up, okay, into the positive and the negative. So the positive one is going to look exactly the same. We just drop the bars. So x plus 1 equals 3. And again, for the negative one, we drop the bars. That stays the same. Just we change the 3 to a negative 3. Now we solve both of these. So subtract 1, x could equal 2. Subtract 1, x could equal negative 4. There's my solutions. And same, if I was going to check this, I'm not going to check both of these. I'm just going to check one. Okay, I would plug it all the way back into my original absolute value. The reason I do that is just in case I made a mistake getting to here. If I plug this answer into this one, it's based off of the mistake that I made. So I want to plug it into the original problem where I potentially haven't made any mistakes in my math yet. I didn't accidentally write something down wrong or goof it up. So if I was going to check my solution of 2, I'm going to plug it into the original absolute value. And I want to see, does this equal 10? So for starters, inside of your absolute value, 2 plus 1 is 3. Okay, the absolute value of 3 is 3. 3 times 2 is 6. And 4 plus 6 is 10. So again, that one checks out. I could do the same thing with the negative 4, but I'm not going to bore you with that. We've got more ground to cover, but it's the same thing. So if I were going to check it though, I would plug it into the original function and check. And again, as far as I'm concerned, those are your solutions and we're done. My math lab, again, you're going to click on the button that has the brackets and you're going to put in your 2 solutions separated by a comma.
Does it matter what order you put the 2 numbers in the solution?
It does not matter. Order does not matter. So just like I put the bigger one first instead of the negative one, which is going to be confusing when we start talking about interval notation, but in this case, no, the order doesn't matter. You're just listing your solutions. You're just saying this one works and this one works. Good question. Okay. Now, like I said, absolute values. It's a key that anytime you're dealing with an absolute value, there is the potential for 2 solutions. And in fact, most problems, 90 to 95% of your problems are going to end up with 2 solutions. There are a couple that don't. So I'm going to show you a couple of the wrinkles you could see. So wrinkle number 1. This is actually some of everybody's favorite problems if you're paying attention. If you're not, then they're not your favorite problems. Because they also tend to make these the most difficult ones. But if you ever see something like this, so we've got the absolute value of whatever, 3x plus 1/2 equals -5. Pay attention and then think about what we're doing, right? What do we know about absolute values? Absolute value is a distance. Whatever's inside of the absolute value has to be what kind of number? Positive, right? Okay, so if this absolute value is positive, and obviously this -5 is negative, can a positive number ever equal a negative number? Nope. This is not possible. Okay, so regardless, whatever they have going on inside of here, doesn't matter. If you have an absolute value by itself and it equals a negative value, you know that will never happen. There are no solutions. There is absolutely no number that you can plug in for X, imaginary, real, or otherwise, that will actually work for this. So if at any point you get the absolute value by itself and it equals a negative, you can jump straight to the fact that it is no solution. And that's one of the buttons on my math lab. So again, they're going to give you the one squiggly brackets. Usually the one here at the bottom is saying that there is no solution. That's the one you would click on. This is a no solution situation. Now, that being said, they may try and trick you and they could do something like this. All right. On first glance, I see an absolute value. I see this equaling a negative. My brain says, shoot, this ain't going to work. But remember, that's only if the absolute value is already by itself. If it's not, we still got to isolate it and then we'll see. So again, if I want to get rid of this 3, I'm going to subtract 3. -5 and -3 is -8. Now, this is one of those tricks that I learned way back in the day. So whenever you see a minus and it's basically being distributed to that, remember it's like saying a -1. So whenever you're subtracting a thing, you're subtracting one of those things anyway. So we can divide by -1. And when we do that now, -8 divided by -1 is +8. And this one actually is solvable. So the rule or the trick where an absolute value equaling a negative is no solution is only when the absolute value is by itself. If the absolute value is by itself and it equals a negative number, no can do. If it's not by itself, get it by itself and then look. Okay, and if it's positive, we can again go ahead and solve. So that'll be x plus 1 equals 8. Or x plus 1 equals -8. X could equal 7. X could equal -9. So again, there's my solutions. Good to go. All right, another wrinkle they can give you is if they set it equal to 0. And the only wrinkle here, the only difference is at this point, you don't need to split it up. There's no such thing as -0. So if we split the problem up, we're going to get 2x plus 1 equals 0 and 2x plus 1 equals -0, which obviously there's no such thing as -0. So there's no need to have two different problems. This is one where you're only going to get one possible solution. So when it equals 0, you're only going to get one solution. If it equals a negative, there are no solutions. As long as your absolute value equals a positive, you should get two good solutions. And again, on my math lab, you would still go ahead and put that into the brackets because it's saying the set of answers is just that one singular number. And typing in fractions, there's a fraction button on my math lab. So when you look at the bottom, there's a bunch of buttons. You can do it that way, or you can just use the division button on your keyboard. You literally type in 1 divided by 2 and it'll put it in as a fraction. So that's kind of convenient. The last problem I want to look at for this section Unfortunately, they do throw some of those fractions in. Okay, don't let the fractions bother you. They behave just like regular numbers. Make sure you have a calculator that can do fractions. It will make this much easier. But the steps are basically the same. So again, I want to isolate my absolute value. I got to get this by itself. Again, the opposite of multiplying is to divide. Now, when you use your calculator, this will make sense, but 5 divided by a half, you're not multiplying those together. So 5 divided by a half is 10. I know that messes with some people's brains, but what you're saying when you divide, okay, like 6 divided by 3, how many groups of 3 fit into 6? It's 2, right? This is saying how many 1/2s can you fit into 5? Well, 10 halves make 5 wholes. Anyway, punch it into your calculator, you'll get the number. It is what it is. Okay, once you get the absolute value by itself, then again, this is where you split it up. X plus 1 over 3 equals 10, or x plus 1 over 3 equals negative 10. Okay, the opposite of dividing is to multiply. X plus 1 equals 30. Subtract, subtract. X could equal 29. Same steps. The opposite of dividing is to multiply. Negative 10 times 3 is negative 30. Subtract, subtract. X could equal negative 31. So they do throw a couple of problems in dealing with fractions. Don't let the fractions bother you. It's all very, very doable. And I think they only throw a fraction in on it like 2 of the problems or so. So it's pretty straightforward. Okay, so that is 2.6. And again, I'm recording this. I'll load this up into Canvas so you have it to look back on. But that's what that first section for tonight is going to look at. 2.7 really combines what we did last time with what we just did. So now we're dealing with absolute value inequalities. So we're still dealing with absolute value. Just now we're dealing with inequalities. Like less than, greater than, less than equal to, greater than equal to. Okay. And also remember, just like last time, when you're dealing with inequalities, there's a few different ways to show your solution. You can do your solution as an inequality. As a graph on a number line. Or in that interval notation. So we talked about all of that stuff last time. If you don't remember that, go back and revisit that lesson. Okay, I'm not going to spend a lot of time explaining these, but this is one where it does matter. Okay, in this grouping symbol, it does need to read from small to big. Okay, you can't go from infinity to 1. Okay, it goes from the smallest possible solution to the biggest possible solution. If it goes forever, that goes to infinity. Okay, if it goes forever small, actually I'll do a less than or equal to just so we can show the different groupings. And actually I should have shown, so again, my math lab likes the parentheses instead of the open dot. So same thing, if it's equal to instead of a closed dot, they like the bracket, the squared off bracket. Less than would shade that way. So then the interval would be from negative infinity to 2 included. So that's just dealing with inequality. So we talked about all of that last time. So you've got inequality answer, you've got a graph answer, and you've got interval notation. Okay, you need to be able to do all three of these. Whenever you work it out, you're going to get this. You're going to type in your answer like that. And then with MyMathLab, it's going to be multiple choice, but you're going to select the correct graph. Okay. Now, dealing with absolute value, so it's the same stuff we just talked about. So again, you go and isolate the absolute value. Then you're going to split into two inequalities, one positive and one negative. Now, very carefully, or very importantly, when you do the negative inequality, that's going to flip your inequality. Whenever I walk you through, I'll talk about it, but I'll make a note of that, but it's important. Okay, the positive one, everything stays the same. When you do the negative one, that flips from greater than to less, from less than or equal to greater than or equal to. Anyway, once you split, you're going to solve, and then you should be able to graph and do interval notation. So I'm going to show a handful of examples. I'm going to start off really easy, and then we'll progress to a little more complicated. And then again, I'll show you a couple of the wrinkles or some of the things they do to try and trick you. So first off, just kind of, again, what the solutions will look like. So I'm going to start super simple. So if I've got the absolute value of x is greater than 5, we're going to split this up. For the positive one, everything looks the same. We just drop the bars. So we get x is greater than 5. For the negative one, it's extremely important that you remember that we got to flip our sign. So instead of x is greater than 5, our sign is going to flip to less than when that 5 becomes negative. So again, for the negative one, you've got to flip the inequality. Okay. For the graph, again, it's important to note the smaller number has to go to the left. The larger number has to go to the right. So if I'm looking at these two solutions, 5 and -5, okay, -5 is the smaller, +5 is the larger. So make sure you have them in the correct place. Okay, next, x is greater than 5, means an open dot. We're going to shade to the right, or parentheses. X is less than -5, open dot or parentheses to not include, less than is over here. So this one shades in opposite directions. It behaves kind of like an OR problem from the other day. Now, the interval notation for this one is kind of goofy. Again, we read our answers from small to big. Our smallest possible answer is forever small. Again, we call that negative infinity. Infinity always gets parentheses. And then we get from forever small all the way up to -5, not included. We also go from +5 to positive infinity. Now, there's another symbol that you need to put in here whenever you have two different groupings like this. There's a U looking symbol. It'll be on the bottom of MyMathLab. You need to put this here. Okay, this means the union of, it doesn't matter what it's called, you just need to put that there. It basically says this one as well as this one. It's saying both of these are good. And really that's what that means. So if I plug in any of the numbers bigger than 5 into my original function, it's going to work. Pardon me. If I plug in a number smaller than -5 into my function, it's going to work. If I plug in any of these numbers in between, It's not going to work. So this is only valid. My only good solutions are less than -5 or larger than 5. So again, this is the interval notation. This is the graphic, or the graph notation, or the graph of the solution. And this is your solution as an inequality. You need to be able to write all three different methods. Again, my math lab is specifically going to ask for these two. You need to be able to correctly solve, and you need to be able to show that answer in different ways. Very similar problem. If I said the absolute value of x is less than 5, and tell you what, let's make it less than or equal to, just to use the other grouping symbol. Okay, same game, split this up. The positive looks exactly the same. We just drop the bars. The negative, we flip. Again, on the number line, smaller number left, bigger number right. And in this case, we're talking about less than or equal to 5. So that's going to go in this direction. Greater than or equal to -5. That's going to go in this direction. Okay, my solution is everything between and including -5 and +5. So the interval for that one says from -5 included to 5 included. And that is how almost all of your solutions are going to graph, okay? If you have an absolute value is greater than, okay, you're going to shade in opposite directions. Interval notation will look something like that. If you have an absolute value is less than, you're going to shade between. Interval will look something like that. That is how almost all of your problems are going to look whenever it's all said and done. Now, again, they're going to make the problems more complicated. They're going to give you some more steps, but your solutions are by and large going to look the same. Now, you're not always going to end up with the same number, positive and negative, okay? But that's by and large what your problems are going to look like. So if we do something just a little more complicated, okay, 1/2 absolute value of 1/2 x minus 1 minus 5 is greater than 10. Same as before. Step one, we want to isolate this absolute value piece. We got to get that absolute value by itself. To do so, we got to get rid of the crap on the outside. Opposite of subtracting is to add. So absolute value of 1/2 x minus 1 greater than 15. Split it up. Positive looks exactly the same. We just drop the bars. The negative we flip. 1/2 x minus 1. That 15 becomes negative. When the 15 becomes negative, my sign flips. We go from greater than to less than. Solve. Oops, I changed it to equal to. Sorry, that should be greater than. So that says x is greater than 32. Solve, add 1, 1/2 x is less than negative 14. Divide, x is less than negative 28. Again, extremely important for your number lines. The smaller number has to go to the left. The bigger number has to go to the right. Otherwise, your directions are going to be all jacked up. Okay. A number line has to read from small to big. Interval notation has to read that same way. So the smaller number has to go left. Okay, in this case, we want all of the numbers smaller than, less than, left of -28. Like so. We want all the numbers greater than, bigger than, larger than, right of 32. So that's all of those. So again, when you shade in opposite directions, that interval looks like that. So again, you're going to negative infinity into positive infinity to those numbers combined with the u. Okay, and if this would have been less than or equal to or greater than equal to, then we would have bracketed those off. And then you would have brackets here, but because it was just less than or greater than, that's why we have the parentheses. Again, extremely important. This is what we're looking for. All right. Like I said, almost all of your problems will end up working like that. Again, there are a couple of things they do that will throw things off. So two very special cases. These do not pop up very often, but you need to pay attention to when they do. Again, absolute values and negative numbers. It's extremely important that you understand how these work, regardless of what the numbers are, regardless of what's going on in here, okay? If you have an absolute value being greater than some negative number, whatever it is, okay? Again, think about this. Absolute values are always positive. So it doesn't matter what you put in for X, this is going to be a positive number, okay? This number here is negative. So what this is saying is, will a positive number ever be bigger than a negative number? And the answer is yes, every single time. Positive numbers are always bigger than negative numbers. So in this case, everything will work. So the graph literally looks like you shading every single possible conceivable number. It doesn't matter what you plug in for X, this is always going to work. So we got to shade everything. And then the interval notation for that looks like that. We go forever small, we go forever big, we hit everything in between. Okay, this is the notation for every conceivable answer, everything. Okay, the exact opposite of that, if you have an absolute value being less than some negative number. Again, absolute values are always positive. This negative number is clearly negative. Can a positive number ever be less than a negative number? No, it is not possible. There is no value that you could possibly plug in here for this that would ever work. In this case, nothing is going to work. So we shade nothing. And there's no interval notation. We just use that empty set symbol. That's the no solution. That means nothing will work, not a thing. Okay, so don't fall asleep on your symbols. Okay, people get used to seeing absolute values and equals, and they're like, oh, boom, no solution. Well, that is unless it's a greater than, okay, because positives are always greater than negatives. It doesn't matter. So you can do anything. So pay attention. These are two very special cases. They don't pop up very often, but they do pop up. And you need to understand what the graphs look like, and you need to understand what the interval notation looks like. Okay, the only other special case that I want to talk about is when it equals 0. Okay, so absolute value of 3x plus 1 is less than or equal to 0. Okay, we can still split this up. So 3x plus 1 less than or equal to 0. We don't need to make the negative because, again, there's no negative 0, so that doesn't really work. So then we solve. So 3x is less than or equal to -1. Divide, divide, x is less than or equal to -1/3. Now, we do have to be a little bit careful with this. Okay, because ultimately, if you look at this, okay, again, an absolute value is going to be a positive number or technically 0. Okay, so the less than doesn't even really matter. We can't ever be less than 0. That would be negative. That doesn't work. But if we plug in this one specific number, okay, that does make it equal 0, and that makes this one specific number a solution. So less than doesn't work. If I plug in something smaller than -1/3, like say -5, okay, 3 times -5 is -15. -15 plus 1 is -14. The absolute value is 14, which is not less than 0. So that doesn't work. But this one specific number does make it equal 0, which would work. So this is a situation where your only good solution is that one specific number. So you don't have to shade in either direction. It is one simple dot on that one number. So when it equals or less than or equal to 0, this is the only possible number that could work. Nothing else will work. So again, that's kind of like the equation. So you put it in squiggly brackets. There is no interval notation. This is called set notation. So those are your 3 wrinkles. Like I said, most of the problems, you get your 2 solutions and they will either shade away if it's greater than, or you get your 2 solutions and you'll shade between if it's less than. And then these are your specials, okay? Greater than a negative, everything works. Less than a negative, nothing works. If it's less than or equal to 0, you're only talking about one very specific solution. There's no shading. It's not a set of numbers. It's just one singular number. Okay, I'm going to do one more example, and that basically closes us out for the night. All right, so again, 2 absolute values of x plus 1/3 minus 3 less than 13. Okay, same game, still get the absolute value by itself. To do so, we're going to do the same step we've been doing. So to get rid of the -3, we're going to add. So keep the 2 out in front. 13 plus 3 is 16. Okay, remember, you don't distribute in to get rid of the 2. We got to divide. So if we divide this by 2, x plus 1/3 is less than 8. From here, this is where we would split it up. Positive doesn't change. When you make it the negative, your sign flips. So less than. Oh, I made that equal to. Well, just to change the grouping, I'm going to make all these equal to. I'm the math teacher. I can change whatever the heck I want. So let's pretend these were all less than or equal to's. So again, when that one flips, it flips to a greater than or equal to. Anyway, solving is the same. The opposite of dividing is to multiply. X plus 1 is less than or equal to 24. So x is less than or equal to 23. Opposite of dividing is to multiply. So x plus 1 is greater than or equal to -24. Subtract, subtract. X is greater than or equal to negative 25. So again, on your number line, smaller number to the left, bigger number to the right. Talking about everything smaller than or equal to 23. Everything bigger than or equal to negative 25. So this is one of those that shades in between. So again, your interval would read from negative 25 to 23. We would use the brackets because it was equal to, and those numbers are included. Should look like so. Anyway, that's it. So we covered, I believe, 2.6 and 2.7, absolute value equations and inequalities. As far as I'm concerned, that's all I'm going to cover. I'm going to be here the whole time. I'll leave the Zoom running for a little while. If you want to stick around and ask some questions, feel free to stick around. If you feel like you got it and you're ready to move on, I'm not going to talk about anything else. So you're free to check out, and I'll see you guys next Thursday. Do get logged into that My Math Lab and start working on your homework if you haven't done so. It's extremely important that you stay ahead of your homework. Okay. Now, also pay attention to due dates. We finished up chapter 2. We're still in the same unit. We're not testing yet, but pay attention to your due dates when stuff is due and make sure you're getting your stuff taken care of. Okay. Anyway, if you have questions, stick around. You can ask them. I'll do my best to answer them. If not, I'll see everybody next Thursday.
So when is the first bit of the assignments due?
Tell you what, let me look. I've got Canvas pulled, or sorry, my Math Lab pulled up on my other one. They are due September 19th. So that's
Sweet.
that's officially when we end the chapter. I would not wait until then. It gives you some time, but I promise if you save yourself like too many assignments and you try to do them all in that last day or even that last couple of days, man, it's a lot of work. It's so much easier if you do it a little bit at a time.
Thank you.
Yep, no problem.